Hi everyone, myself is Subramanian, working as Associate Professor in the Department of Pharmaceutical Chemistry, SNS College of Pharmacy and Health Sciences.
Hi everyone. Now we are going to discuss about the benzoin condensation. So what is this benzoin condensation? So this benzoin condensation reaction can be defined as the reaction between two kinds of aromatic aldehydes, especially benzaldehyde, in the presence of catalyst which may be either nucleophilic or heterocyclic to form an aromatic parent compound. So this is a reaction between two kind of aromatic aldehydes, and the aldehyde may be especially benzaldehyde, so in the presence of some catalyst. So that catalyst may be a nucleophile or heterocyclic compound to give an aromatic parent compound. Benzyne condensation involves three-step condensation. So now we are going to discuss the first step. Here, nucleophilic addition of a cyanide with benzaldehyde to give cyanohydrin. Here we will, in first step we will see the structure of benzaldehyde that will be reacting with the cyanide group C6H5CHO Cn minus, which will give the intermediate C6H5CHO minus Cn. This um, intermediate, that is anion, will attack the water molecule with the elimination of hydroxyl group. OH minus will be eliminated, which will give, so the hydrogen will be added to the O minus anion, which will give the intermediate cyanohydrin. So C6H5CHOH Cn will be formed. So benzaldehyde will be converted into cyanohydrin. This is the first step. This benzyne condensation reaction is used for the synthesis of various organic compounds and in reactions. So it is useful for the synthesis of various organic compounds, and it is also used in various chemical reactions. So it is used to extend the aliphatic form of aldehydes. So it is useful for the extension of the aliphatic form of aldehydes, and it is used for the synthesis of heterocyclic compounds. So this benzyne condensation is useful for the synthesis of heterocyclic compounds, and it is also used in polymer chemistry. This benzyne condensation is used in polymer chemistry also. So benzyne condensation is an important reaction. So we have discussed about the what is benzyne condensation, what is the mechanism behind this benzyne condensation, and what is the application of this benzyne condensation. I hope you could understand the reaction of benzyne condensation, its mechanism and applications. Thank you. The third step is rearrangement reaction, removing the cyanide group, resulting in the formation of benzoin. So here we are removing the cyanide group that will give the compound benzoin. So intermediate compound, that is C6H5CO minus Cn to this C6H5HOH will be attached. So here we are removing this cyanide group so that it will be converted, the O minus will be converted into double bond O, so that benzyne will be formed, that is C6H5 C double bond O CHOH C6H5 will be formed. That is the structure of benzyne. So the third step is rearrangement reaction, removing the cyanide group, resulting in the formation of benzyne. So C6H5CO minus Cn CHOH C6H5 will be converted into C6H5C double bond O CHOH C6H5. So cyanide group will be removed, so double bond will be formed between the carbon and oxygen. So benzyne will be formed. So this is the mechanism behind the benzyne condensation. It involves three steps. The first step is nucleophilic addition of a cyanide with benzaldehyde to form cyanohydrin, and the second step is condensation reaction between the cyanohydrin and a second benzaldehyde And the third step is rearrangement reaction. In this reaction, the cyanide group will be removed to give the final compound benzyne. The second step is the condensation reaction between the cyanohydrin and a second benzaldehyde. So here we will find the reaction in which cyanohydrin will react with the hydroxyl group, that is C6H5CHOH hydroxyl group will be added, OH minus will be added, that will eliminate the water molecule, which will give the intermediate C6H5COH double bond C double bond N, that will be added to another one aldehyde, benzaldehyde will be added here. So here the intermediate will be formed, that is C6H5 COH C6H5 O minus and H. This intermediate will be added with the water molecule. So O minus will be added with the hydrogen ion, that will be converted into OH. So OH minus will be eliminated, which will give the intermediate C6H5 COH CN C6H5 HOH. That will be added to the another one hydroxyl anion, that is OH minus will be added here. So here water molecule will be eliminated to give the intermediate compound C6H5COH C6H5HOH. That intermediate will be formed here. And the next step is removal of hydrogen to give the intermediate compound C6H5CO minus CN C6H5HOH. This is the second step, that is condensation reaction between the cyanohydrin and a second benzaldehyde.